Hey everyone, so we are continuing our unit on functions, and today we're going to be focusing on finding the domain given a graph. Okay, so first let's refresh our memory on what a domain is. The domain of a function is the set of all first elements of ordered pairs. The domain can also be called the x-coordinates or inputs. It's also known as the independent variable. And for today, on a graph, the domain is represented by the x values that make up a function. Okay, so when we are looking at the domain or the range, which we're going to talk about tomorrow, there's three different scenarios that we're going to be seeing. The first one is an open circle. So if you remember our unit on graphing inequalities on a number line, the open circle means that that value is not included in the inequality. And it's the same thing that applies to the domain and range of function. If there is an open circle on a graph, that means that value is not included in the domain or the range. But today we're only looking at the domain. Okay, and open circles will look just like this. It'll be an open circle on the graph. Then we have a closed circle. That means the x value is included in the domain. Also, if there is no open or closed circle, it's safe to assume that it's a closed circle, that that value is included in the domain. And we'll see either a closed circle or no circle. Okay, and then the last one is an arrow. That means that it's going to continue. We know what an arrow looks like. That means that that domain is going to just continue on and on and on and on past what we can see on the graph. Okay, so let's take a look at some examples so you get an idea of what this is going to look like. Okay, so here we're given this graph. It's kind of like this squiggly line. We have an open circle and a closed circle, and we want to identify the domain from this function. So the first thing we're going to do is highlight the x values of this function. So we're only looking at the x values. Pretend like the y values and the y-axis doesn't even exist. So basically, we're going to be looking at how wide this function is. So when I say highlight the x values, what I do is I go from the end point, which is over here. So I know we're going from here to our starting point, I guess, to our end point, which is right here. So remember, I'm only looking at these x values. So this is how wide this graph is. Okay, so it's going from here to here. Now, once we have that highlighted, we see, okay, this is a -3, it's an open circle, and this is a 1 closed circle. So -3 is not going to be included in our domain, and 1 is going to be included in our domain. So if you want, you could even write the numbers above it or next to it, so you know those are the two numbers we're focusing on. Okay, so now that we have those numbers, we are going to write this as an inequality. So what this means is every number in between, but not including, -3 and 1 is included in this domain. So that means -2.5, -2, -1, 0, 0.5, and 1. So, and then every other decimal in between. So this is how we're going to write it. -3 is less than x, which is less than or equal to 1. And I'll explain why there's a difference in these inequalities. So like we said, -3 is not included in this domain. So it has to be all the numbers that are bigger than -3, but less than -1, but that does not include -3. So we're not going to have that or equal to. So basically, just like when we learned about inequalities, if we have an open circle, we do not have that or equal to part, which is that little line underneath the inequality. Now, because 1, there's a closed circle, that means that 1 is included in that set. So we have that or equal to because 1 is in that domain. Okay, so open circle, we're not going to have the lines underneath. Closed circle, we are going to have the lines underneath. Okay, and like I said, this means every number, but not including -3, so in between -3 and 1. Okay, let's look at another example. Okay, here we have an arrow, but we're still gonna do the same process we did before. So we're gonna highlight the x values, only focusing on how wide it is. So on Delta Math today, it might just be a line that stops, and no circle, no closed circle, so that's safe to assume closed circle. I know that seems a little confusing, but basically if there's no open circle, you can just assume that that number is included in the domain. Okay, so we have our starting point here, which is -4, closed circle. So we have -4, and then we see that it's going to keep going on and on and on. So what that means here is this domain is represented by all the numbers that are bigger than -4, including -4. Okay, so every single number that's bigger than -4 past 5, because we have that arrow, so 6, 7, 10, 20, a million, those are all part of this domain. So to write this inequality, we're going to write x is greater than or equal to -4. You could also write it like this: -4 is less than or equal to x. These mean the same thing, but it's basically saying any x value bigger than -4 is in this domain. Okay, let's look at a multiple choice question that has been seen on the region in the past. Same process. Says the effect of pH on the action of a certain enzyme is shown on the accompanying diagram. So we have this pH balance, and we want to identify the domain of this function. So remember, domain are x values only. We're not even paying attention to the y values. So that means we can cross out 2 and we can cross out 4. This is talking about the y values. We're not concerned with the y values, so we're not even going to focus on that. And the same thing, we're going to look at how wide this is. So we can see that our starting point is 4 and our ending point is 13. So that means all of the values, all of the x values from 4 to 13, those numbers included because we don't have any open circles, that makes up our domain. So that is choice 1. Every number in between and including 4 and 13 are part of this domain. So the more you practice this, the better you're going to get at it. But when you're focusing on the domain, only look at the x values and try to create this like kind of scale and highlight where your starting point is and where your ending point is.